So we will discuss the first 7 problems in div 4. It is like the first 4 problems of div 2 and the first 3 problems, or yeah, I think the first 3 or 4 problems of div 1 as well. So starting on with the very first problem, glass prices. The problem says that okay, chef is buying spectacles and he has 2 choices. Plastic frame costs X rupees and the metal frame costs Y rupees. Basically, the problem is saying that chef is going to buy something. There are 2 variants. The first variant is metal and the other variant is of plastic. So the plastic variant costs X rupees and the metal variant costs Y rupees. And chef will buy the metal frame if and only if the cost is at most twice per the cost of the plastic frame. So basically, if y is less than equal to 2 into x, in that case, chef will buy the metal frame. Otherwise, chef will buy the plastic variant, right? So that's it. We just have to take x and y as input and have these if-else conditions for solving the problem. Uh, this was a very beginner friendly problem, and anyone who just knows about taking input output, like taking inputs and printing outputs and if else conditions, can solve this problem. I think we can move on to the next problem. This problem didn't really have any difficulty. Yeah, so this is the second problem. The problem says that Alice and Bob invented a brand new algorithm, but they can't decide what to name it. Alice suggested a name SA and Bob suggested a name SB. Both of these are strings of containing of lowercase English letters. And Alice thinks that Bob's naming sense is really bad. So she will only be happy uh, if the name given to the algorithm is not close to SB at all. More specifically, Alice will be happy if and only if the name of the algorithm does not share any characters with SP. Similarly, Bob will be happy if the algorithm's name does not share any characters with SA. So, is there a way to name the algorithm so that both Alice and Bob are happy? And we should use only the lowercase English letters. So, let me explain the problem. There is some algorithm developed by Alice and Bob. Alice named it as SA and Bob, like whatever name Alice gave is SA and Bob gave is SB. We would be given these 2 strings. So Alice thinks that Bob's naming sense is really bad. So let's say if Bob gave the name ABCD, then Alice wants that the actual name which would be given to the algorithm, let's say it is called as answer, or maybe let's call it as S, the name given to the algorithm, it should not contain either of these characters. So if the name given to the algorithm is something like EFGH, then Alice is happy. But if the name contains any of these characters, let's say EFGHA, then Alice would be sad that this is a name which is having some resemblance to Bob. Basically, it is having something which is matching with the name Bob suggested. Similarly, Bob also wants that the name should be completely different from whatever Alice suggested. So if Alice had suggested HIJK, then Bob would also be sad that, hey, both of these are having a common character. So I hope the problem is clear. We just have to tell if there is any possible string such that none of the characters of that string matches with any of the characters from either of the strings. So S should not have any character in common, should not have any character in common with um, SA or SP. Does it make sense? Just say yes or no. Does it make sense? Yeah. So the logic is pretty simple. Whatever name Alice suggested, you can just keep track of all the alphabets which are coming in that theme. Similarly, whatever name Bob suggested, you can just keep track of all the alphabets which came in that word. And then you would know about all the alphabets which should not come in the name of the algorithm. So if there is any alphabet which is not like from the alphabets from A to Z, if there is any alphabet which has not come up in either of these strings, basically in both of these strings, if there is any character which is not coming, let's say the names which Ali suggested was A, B, C, D, and with the name which Bob suggested was D, E, F, G, then if you have any character, like here in this case, you have a character H, which is not coming up in any of these, you can just name the string equal to H. है ना? Like it is a weird name for the algorithm, but at least there is a possible name which does not contain any alphabet which is coming up in either of them. है ना? So this is the logic. You can just iterate over the complete strings, look at the characters which are coming up in these strings, and then just see if any of the characters from A to Z has been missing in both of them. If you find out that character, then the answer is yes, otherwise no. So does it make sense? Maybe we can take one example as well. Let's take this example, Dijkstra and Blossom. So in this case, you would first of all check for A. A is coming up in the first string, so this uh, like then you will check for B. B is coming up in the second string. Then you will check for C. Since C is not coming up in either of these strings, so you can just say that, hey, I will name the algorithm as C. And then you can say that, yeah, since C is not coming up in either of them, both of these people will be happy. So uh, there is a possibility, there is a possible algorithm name where both the people would be happy. Now in the code which I have written, what I did was I just I just calculated the frequency of each and every character from both of these strings and stored it inside a vector with name count. And then for every character, I just checked that if the frequent if the count of I is equal to zero, there where the for loop is going from I from 0 till 25, then in that case I said yes, otherwise I said no. But I think the solution which we just discussed is simpler, so maybe I can just write the code in front of you very fast. Uh, so as we discussed in the logic part, we would like to go character by character, है ना? So we would like to go for character from A till Z, and then for each and every character you would like to just check if it is absent in both these strings or not. So you would go like bool okay equal to true, and then si equal to ch, take, and similarly if just 1 minute, and I will explain the code. The previous code which I had written, I think it was a bit difficult for being the second problem of a Div 4 contest. So that is why I'm writing the simpler code. Uh, okay, good, false, and sorry, if you have an okay, then you can say found equal to true and then break. So I think it should be correct. Just let me verify and then I can explain the code. Successfully executed. Yes, no, yes, you're not belonging to this division. Okay, I can't submit the code right now. I think I can. Yeah, let me just verify if the. Okay, nice. So as we discussed in the logic part, first of all, obviously we'll take the inputs. Maybe let me remove this part. You will first of all take the inputs for every test case. And yeah, till this part, you're just taking the inputs. After that, we want to find out if there is any character which is not coming up in both these strings. So we will go character by character. We will have a for loop for going character by character from A to Z. Then for every character, we will iterate over both the strings and check if there is any character which is equal to the current character for which we are checking. So if we find out, then obviously we need a boolean which will tell us that hey, we did find out a character which was equal to ch. So we maintained a boolean variable. And after that, if the boolean variable is true at the end, it means that you did not find out any character equal to ch in both these strings. So in that case, you can set found equal to true, that you found a character which can be used in algorithm, and you can just break for now. And at the end, the answer is yes if you did find out any such character, otherwise no. So I hope this code makes sense. Let me look at the chat. Okay, so somebody is saying I put all the characters of B and C in a set and then calculated the set size. Oh yeah, that can also be good. Yeah, that is also a good way. You can just put up all the characters of these sets inside in of these strings inside a set of characters. Now, if the size of this set is equal to 26, in that case, it means that all the characters, all the alphabets have been coming up in both these strings in total. And if the size is less than 26, then it means that there would be at least one character which is not coming up in both these strings. So you can just print it. So if you knew about sets, you can do it like this as well. Otherwise, you can always do the brute force way, which is just using for loops and nothing else. Okay, so shall we move on to the next problem? I hope this problem is clear. Okay, nice. So let's look at the third problem. The first two problems were from Div 4 and they were pretty simple. Now this problem came as the first problem of Div 2, and it's not difficult either. So the problem says that we have been given an integer array a of length n plus 1 denoted by like basically this is denoting a1 to an, these integers, and we can perform the following operation on the array a, where we choose an integer I from 1 to n. I can be anything from 1 to n, and this condition should be satisfied that ai is less than equal to 2 into a of n plus 1. Then we can swap ai with a of n plus 1, and that is you can swap any element swap the element n plus 1 with some element of the array that is at most twice of as large as it, and we can perform this operation as many times as we want, even zero number of times. What we want is the minimum possible value of the sum of first n integers of the array. So we had been given some array a which was having the size n plus 1, and what we could do was choose any I from the first n natural numbers, basically choose any I from 1 to n, such that a of I is less than equal to 2 into a of n plus 1, basically whatever element is present at the end. um, the element you choose should be less than or equal to twice of that, and let's say you chose this I, then you can just swap both of these elements, swap both of these with each other. So if you had an array like 1 2 3 4 5, and then maybe 2 is coming up here, this is the array given to you, then in that array, if you choose this as the I, then ai would be equal to 3, and a of n plus 1 is equal to 2. So here this condition is satisfied, ai is less than equal to 2 into a of n plus 1. So you will be able to swap both of these with each other. So you will have a 2 coming up here and a 3 coming up here, and the array will become 1 2 2 4 5 3. I hope it is clear on how we can make a swap, on how we can apply the operation basically. And our goal is to find out the minimum possible value for the sum of first n elements. So you have been given an array of size n plus 1, and you want to maximize the sum of first n natural numbers, है ना? Can I say that this is nothing but the total sum of the array minus the last element, है ना? The problem is indirectly asking you to just find out this maximum possible value for sum of a minus last element, because there are n elements and the sum of the first n would be nothing but total array minus the last element, and this thing is constant. Like if you are being given an array and the values of the array are gonna be the same, you can just change their positions, so the sum of the array will always remain the same for a particular array. But this value can be changed by applying the operation. You can apply an operation and swap elements, so this a of n plus 1 can be changed. So can I say that the problem is indirectly asking me to find out, oh sorry, we had to minimize this, we had to minimize this thing here. The problem asked us to minimize sum of a minus a of n minus n, a of n plus 1. So for maximizing a constant value minus some variable, can I say that if I maximize a of n plus 1, in that case this expression would be minimized? Can I say this? Guys, please say yes or no. Are you with me right now? Did you understand till this part? Okay, great. There is one more observation I would like to make. This is a really good observation, works in most of the problems for Codechef. Actually, a lot of problems. Well, like you are being given an array now. Just try to think about it once. Does it really matter in which order the elements are? If the array, instead of being 1 2 3 4 5 2. If it was 1 3 4 2 5 2, would the answer for this particular array and this particular array be same or different? My claim is that the first n elements, like for the first 10 elements, it doesn't matter in which order they are coming, as long as they are the same numbers. If you are having 1 2 3 4 5 at the first n positions, even if you swap them with each other, it won't really change the answer. Because if I wanted to perform an operation between this 2 and then this 3, I can still do this. Only the index, basically only the position of the element is changed, but the element is still there. है ना? Um, and even if you didn't make this observation, you could still solve the problem. And yeah, the element which is coming up at the last position does matter, because if you had an array like 1 3 4 2 2 5, it will have a different answer from this. Like it may have same answer, it may have a different answer, because uh, in the operation which you were making, like if the last element was the same and only these people were being shuffled with each other, um, this only this I value was changing, right? By just changing the I value, you could choose this three. Like it didn't really matter whether this three was present here or here. But if you're having a value like 5 here by default, uh, now in this case, this a of n plus 1 has been changed, है ना? And in some cases, like if instead of 5, let's say instead of 5, if you had a number like 9 here, then the answer for these two arrays would have been different, because you could never choose the uh, 9, like you could never choose AI as 9, as 9 would have always been greater than 2 into a of n plus 1. But if you are having 9 at this position by default, you will be able to have it at this place, whereas in this case you can't. So basically this discussion which I had about the permutations, different permutations having the same answer, is a generic observation which we make to uh, realize that you don't really need to keep the same order. You can just sort the array from in this range. And in case if it looked confusing, then just skip that part. It's not really necessary. I just wanted to cover a generic approach. The main idea is, like, just forget about all the discussion we had right now. If in case it looks confusing, the main idea is you want to maximize a of n plus 1, right? This is our goal. So whatever array you have, let's say we have this array 5 2 1, 5 2 1 2 3. You want to maximize a of n plus 1. The only way for changing a of n plus 1 is by choosing some element and then making swaps. So would it ever make sense to choose either of these three elements and swap it with the last guy? Hmm? Obviously, it won't make sense. You want to maximize this value, so you would never swap it with anyone who is smaller than the current guy, which is at the last position. And for the large, and for this guy, which is 5, the largest guy right now, would you like to swap them? Yeah, you would like to swap them. You would like to make this element as big as possible. So one thing which we can definitely say is, if there is any AI which is less than equal to 2 into a of n plus 1, and uh, and AI is greater than a of n plus 1, then you would definitely make a swap. You are in this way making the value of AI larger, and that's it. You are able to make a swap and you are making the value larger. In case if AI is less than or equal to A of n plus 1, then applying operation wouldn't make any sense. Nextly, if there is any element which is even greater than 2 into A of n plus 1, you can't really make any swap. So in that case also, you won't make any swap because you are not permitted. So now we have got a general idea that you want to maximize A of n plus 1, and for that you would like to just swap it with larger elements. Now what is the largest element? If you have any array, let's say you have an element array like 12483, then obviously you would like to swap the current last element with 8, है ना, and make it as large as possible. You would like to swap it like this, but in this case 8 is greater than 2 into 3, so you can't really make a swap right now. But if you swap this 3 with 4, then in that case you can have the array as 1 2 3 8 4, and then you would be permitted to swap these people, है ना? And I think they would have given such example as well. Yeah, let's look at this example. 16 4 8 2 1. 16 4 8 2 1. Yeah, so in this given example, you can't really make a swap between 1 and 16 right now. But if you swap 2 and 1 first, you will have a 2 coming up at the last position. Then you can make a swap between 4 and 2 to have a 4 at the last position. Then swap 8 and 4 to have 8 at the last position. Then swap 16 and 8 to have 16 at the last position. And you would be able to get the last element at the last position. Sorry, the largest element at the last position. And your answer, which is nothing but sum minus A of n plus 1, would become equal to the sum is 31 minus 16, that is equal to 15, right? That is the answer. So from the example as well, you could have got this idea that maybe just swap the current A of n plus 1 with the with any value which is coming up in the range from AI, sorry, any value AI which is coming up in the range from A of n plus 1 till 2 into A of n plus 1, है ना? For that, what can be the best way? You can say that among the people who are in the first 10 elements, I will just go from smaller to larger, है ना? I will just sort them and then go from smaller to larger. And I have this last element, let's say last is equal to 1 right now. I would compare these people. If I have this current guy being less than equal to, like if this 2 is less than equal to A of n plus 1, then I will just skip and don't do anything. Otherwise, if this current guy is greater than A of n plus 1 and less than equal to 2 into A of n plus 1, then I will make a swap. And if I find out, like if I reach an element, let's say if after 2 we had 5, then initially you would have made a swap. You would have swapped the last element with the current guy and you would have got 2 at this position. Then on the next guy, if you find out an element which is even greater than 2 into A of n plus 1, then you can just break your traversal. You don't really need to check out any element in the future because you won't be able to make any swaps with anyone. So guys, does it make sense? I think I over explained. Okay, so somebody is asking what were my observations. Um, Initial observation was only this, that the problem is indirectly asking me to maximize A of n plus 1. Then this observation that if AI is less than A of n plus 1, then I should never make any swap. In this case, I should make a swap if the AI is greater than A of n plus 1 and less than equal to twice. And in the case if AI is greater than 2 into A of n plus 1, then I can't make a swap. And then this observation that I might not be able to make a swap with the largest element directly, but if I just make swaps with the elements who are just greater than me, and I can make swaps with them, then just make a swap. It is making things better and never worse. And eventually I might be able to make a swap with the largest element as well. So I thought of just uh, sorting the array, that sort the first n elements of the array and go from left to right. Check for each and every element. If it is less than or equal to A of n plus 1, then no need to swap, just continue. If the element is greater and you can make a swap, then make a swap. And if you can't make a swap, if you reach a position where you can't make a swap anymore, then just break out. So here is the code. First of all, I'm taking the inputs. Uh, Ignore these two lines. These are just for making the input output faster, the C in C out part. So here I'm taking the inputs. After that, I sorted the first n elements of the array. After that, I went from left to right in the array. And if I find out an element which is less than equal to an, in one based indexing, we were saying A of n plus 1, but in C++, we have zero based indexing. So it is A of n here. So if AI is less than equal to A of n, then just continue. If AI is greater than 2 into A of n, then you can't really make a swap. So just break out. And otherwise, you just swap with the last element. And eventually, the answer would be sum minus the last element. I hope the problem is clear. Please say yes or no. If you have any doubts, then please ask. Clear. Great. What about others? Okay, let's move on to the next problem. Okay, this was the first problem of Div 1. Small, smaller, smallest. The problem says that we have been given a binary string s of length n. We can perform two-step operation on it. Choose a non-empty contiguous substring of size s. Sorry, contiguous substring of s, of the string s. And then if the substring contains an odd number of ones, delete every zero in it. If it contains even number of ones, then delete every one in it. So they have given an example that if the string looks like this, 101 001 or 0001. Yeah. So if the string looks like 101 0001 and you chose the string substring 101, you chose this substring, then it contains two ones and one zero. You know, this is even number of ones. So for the case even, we will delete every one in it. So we will delete this one and this one. And the string will now become, the string will now become 00001, like this. In the other case, if we had chosen 1 000, if from the string 101 00 0001, if we had chosen this part, then we would have got 1 1 and 3 zeros. So we have odd number of ones here. And if we have odd number of ones, then we will remove all the zeros. So we will delete all the zeros here. So the resultant string will now be 1 0 1 1 1 0 1 1. And we can perform this two-step operation as many times as we like. We have to find out the minimum possible length of the final string. So our target is minimize length of S. This is our target. So let's start on with the very basic observations, the initial thoughts you might have. Um, Basically, just thinking about the simplest cases. What if the given string S contains all zeros? In that case, whatever substring you choose will always have zero ones and some number of zeros. है ना? It will have some zeros, but you don't really care about the number of zeros. It will have zero ones, which means that it has even number of ones. And for even number of ones, you will delete all the ones. Since it does not have any ones, nothing will happen. So if you have a string S which does not contain anyone, then the length of the string will just remain equal to n because you can't really do anything on it. Similarly, you would think about another simple case, that what if there is a string is containing only which contains only the uh, character 1. Then in that case, whatever substring you choose will have some ones and zero zeros. Now, depending upon the length of the substring, if the length of the substring is odd, then you will have odd number of ones, otherwise you will have even number of ones. So there can be two cases, either the number of ones can be even or odd. If the number of ones is even, in that case you would delete all the ones. No. So whatever substring you chose would be deleted if the number of ones was even. If the number of ones is odd, then all the zeros will be deleted. Since there are no zeros, nothing will happen, and this kind of operation is useless, right? So if you have a string which contains only ones, then eventually, like, the only way in which you can reduce the size of the string is by choosing even length substrings, which will remove all the ones in those substrings. So basically, whatever the length of your string was, it would be reduced by some even value. So if the length of the string initially was odd, then at the end of the day, it would still remain odd because you are removing some even value from it. If the length of the string was even, then still it will remain even because you have been deleting some even value only. We are removing substrings of even length. So if the length was even, then the smallest value you can have is 0. If the length was odd, then the smallest value you can have for the string is 1. So these were the two simplest cases you could think of, either having all zeros or having all ones. Now, in general, you will have some zeros and some ones, right? You would have something like this. So now we should think about what we can do. What can we do? Since we want to reduce the value as small as possible, uh, or yeah, like we want to make the size of the string as small as possible. Let's do one more thing. Let's think about all the uh, operations which we can apply. The basically the simplest operations which we can apply. Someone might say that, hey, I will choose a substring of size 1. No, what if we choose a substring of size 1 for applying the operation? Then what will happen? Either the substring will be 0 or 1. No, the character which you have picked up would either be 0 or 1. If it is a 0, then the number of ones is 0, which is even. So you would delete all the ones. Since it does not have any one, nothing will happen. It does not make any sense to choose a substring of size 1 which is equal to 0. Similarly, if it has a 1, the number of ones is odd, so you would delete all zeros, but it does not have any 0. So in a nutshell, you can say that choosing any substring of size 1 wouldn't change anything in the string, so it makes no sense to apply that operation. Then you would think about choosing substrings of size 2 for making the string smaller. So basically, the reason we are doing this hit and trial is because on Codechef at least, the problems uh, are generally just observation based. So if you're experienced, you might just directly be able to look at the, like you might just directly be able to think of the way in which we can make the size as small as possible. Otherwise, you would just try to do some hit and trial so that you might be able to find out the observation. So if you were trying to think of simple observations, then you would have seen that for size 2, there are three possibilities, either both zeros or both ones, or a string having 1 0 and like it is having 1 0 and 1 1, one occurrence of 1 and one occurrence of 0, or two zeros or two ones. Now, if the string is having two zeros, then nothing will change. We already know that if a string is having all zeros, we can't really do anything. So we can't do anything. If it is having two ones, in that case, it will just become equal to an empty string. So yeah, this can be a useful operation. Or if you have a 0 1 or a 1 0, in this thing, you have odd number of ones. So you will delete a 0. So you will have only a 1 left. So this is somewhat like you used a 1 for deleting a 0, which was coming adjacent to it. And this is actually a very uh, common thing. Like I have solved a bunch of problems during contests where this was the observation required, or basically just observing this thing solve the problem. That whatever string I had been given, let's say this was the string 1010001, then if you had chosen something like 10, you could have got rid of a 0. You could have reduced the size of the string by 1 by getting rid of a 0, and you still have that 1 left. So you can again use it to get rid of another 0. Then you can again use it to get rid of another 0. Then you can again use it to get rid of another 0. So you would eventually have only ones left. Does it make sense? If you are having a string which is having at least one occurrence of 1 and at least one occurrence of 0, then that string will either have a 0 1 or a 1 0, at least one occurrence of 0 1 or at least one occurrence of 1 0 in the string. है ना? Because there must be some point where 1 and like this 1 and this 0 are adjacent to each other. So at that place, you can just pick up those substrings one by one to get rid of all the zeros. So your string will have only ones left. You will have only the ones left in the string. And when you have only ones left, you already know what to do. You know, if you have only ones left, then depending upon the number of ones, the count of ones, let's say the count of one is odd, then the answer is 1. Otherwise, the answer is 0. Right? Does it make sense? I just try to approach the problem in a way that if you are looking up at something like this for the very first time and you might get some other ideas as well. You might try them out as well. But uh, a general way for solving problems where you already know that they would be just some tricky problems and it won't really require much of coding concepts. So you would try to think of the simple ideas you get after reading the problem, right? You would try to get think of such ideas that what if the complete string is having all zeros, or what if it has only ones, or if it has zeros and ones, then there can be multiple ways in which you choose the operation. So let's try to think of something easy, that what if I choose substrings of size 1 only, or what if I choose substrings of sizes 2. So in that case, you can notice that uh, choosing a 0 1 or 1 0 can get rid of a 1, can get rid of a 0. So basically giving you an idea that you can use a 1 for removing the zeros adjacent to it, and even the zeros which were adjacent to the adjacent of the current guy. Now uh, just for more clarity, let me just show you a dry run as well. So for the let's take one example from here. Let's say that this is the given string 0 11 0 1, 0 11 0 1. So first of all, you can choose any substring which contains a 0 and a 1. So you will get rid of the 0 and you will have 1 1 0 1. Then again you can choose any substring which will have a 0 and a 1 to get rid of another 0, and now you will have only ones left. As soon as you reach the state where you have only ones left, you know that now the answer will depend upon its length. So since the length here is 3, which is odd, the answer will be 1. है ना? And the way you would make it equal to 1 is like maybe just still pick up substrings of sizes 2 2 2 and so on until you have only one character left. So I hope it makes sense. It will be 0 now. No, answer will be 1 here, because you have 3 ones left in the string after removing all the zeros. So uh, in one operation, you know that if you choose an odd length string, nothing will happen, because in an odd length substring, zeros will be removed and there is no 0. And if you choose an even length string, then that even length substring would be removed. So you can just remove some even length substring from the given string. So eventually you would have a character left. Okay, great. So let me show you the code. In the code, after taking the inputs, I first of all checked for this edge case, that what if all the characters are equal to 0? In that case, the answer will be n. I can't really do anything. Otherwise, I counted the number of ones, because after removing the zeros, I would have only the ones left. And depending upon the number of ones I have got, um, my answer would be nothing but, if the number of ones is odd, then the answer would be 1. If the number of ones is even, then the answer would be 0. So if the number of ones is denoted by ones, then I can just say the answer is nothing but ones mod 2, right? Because for even it will return 0, for odd it will return 1. So that's how I have written this code. So I hope this is also clear. Let's move on to the next problem. Normal is good, easy part. So this problem was present in div 4. It was not present in div 1 and div 2. The harder version of this problem was present there. The problem says that we have been given, okay, let me explain the problem here itself. So in the problem, first of all, we are being told that if you had an array of length m with the name b, it would be considered normal if the mean of this array is equal to its median. Basically, if the mean and median are equal, then the array would be considered normal. Otherwise, it won't be considered normal. And the median is defined as the element present at the index m by 2, a seal of m by 2. And for the mean part, you just take the sum of all elements and divide it by m. So for an array like 1, 2, 1 comma 2, by the way, they have been taking one based indexing right now. So in one based indexing, the indices would be 1 and 2. So here the mean would be 2 by 2 seal, that is nothing but 1. So this would be the median, and the mean here would be the sum of these 2 by 2, that is 1.5. I hope everybody already knows how to find out mean and median. Mean is nothing but the average of all numbers. Actually, average mean of all numbers is nothing but the sum of all numbers divided by the number of numbers. And the median is the middle guy. If you sort all the elements, like if you sort an array, uh, then the middle guy is known as the median, and the mean is gonna be the sum of these by 5. So 1 plus 2 plus 3 plus 7 plus 8 by 5. This would be the mean. So I hope it is clear on which array is considered to be normal. The mean should be equal to median. And we have been given an array A containing n integers, where every integer would be either 1 or 2. And we have to count the number of contiguous subarrays of A that are normal. So let's take some example. 2 2 1 1 2. Let's say A is equal to 2 2 1 1 2. We have to find out the number of subarrays of A which are normal. So in this case, the subarrays of A would be 2 2. Okay, let me write it like this: 2 2 2 2 2 1, and so on till 2 2 1 1 2, then 2 2 1, and so on till 2 1 1 2. Then similarly, the subarray is starting from this place, that is, maybe let me just write everything here: 2 2 1 1 and 2 1 1 and 1 1 1 1 2, and then 1 and 1 2, and then 2. These are all the 15 subarrays of this array. Now the ones which are normal here, let's go one by one for them. Like if you had not been able to think of any idea after just reading the problem, then obviously you would just try to look at the sample test cases and solve them manually to look at the to get some observations. So I'm just doing it in the very simple way on how a beginner could have solved it. So here the mean and median would be 2 and 2, right? So this is a normal array. Here also mean and median would be 2 and 2. This is also normal array. In this case, the mean would be equal to 2 plus 2 plus 1 by 3, that is 5 by 3. And the median would be 2 here, because sorted, like the array after sorting would look like 1 2 2. Hai na? So this is the middle guy. And This is not a good array. This is not a good subarray or the normal subarray. Then in this case, the mean would be 2 plus 2 plus 1 plus 1 by 4. Yeah, so it would be 6 by 4, that is 3 by 2. And the median would be uh, 1 here, because after sorting the array will look like 1 1 2 2, you know. So the median would be 1. I hope you noted something here. Like, you don't really need to solve for all the subarrays. The point behind starting was that you might get some observations. Like, one observation you might have got till now is the median would always be an element which is actually present, है ना, in the subarray. So median would always be an integer. Median would either be 1 or 2, है ना, one of these two. But for mean can be a decimal value as well. In fact, if you are having any subarray containing a 1 and a 2 and anything, basically the subarray contains both 1 and 2, then the mean value would be greater than 1 for sure and would be less than 2 for sure, since you have only ones and twos in the array. So mean would definitely be a decimal value in that case. The only case where the mean is an integer value is if all the values of the subarray are either 1 or all the elements of the subarray are 2. If you have both 1 and 2 coming up in any subarray, in that case, the subarray would have a decimal mean. You, like, some people might have realized this till this point. Some people might have realized even before thinking about these subarrays. Some people might have to uh, like do some hit and trial till some, like, for some more examples. Basically, some people might have to put up some more efforts, but everyone could have eventually figured out this part if you had put up efforts. So now the idea is simple. We can say that the problem is indirectly asking us to find out number of subarrays where all elements are equal. You can say the problem is like this. And there are only two type of elements. The value of AI can either be 1 or it can be 2. And the size of the array can be pretty huge, I think. It can be up to 3e5. That is 3 into 10 raised to the power 5. So guys, are you with me right now? How many of you are with me? Just say yes or no. What is this? Oh, okay. Sorry, I missed a doubt in the last problem. Somebody was asking what is the function string n comma 0. It will just return you a string of size n which is having all zeros. So uh, you can just write a code like this whenever you want to check if string is having all elements which is equal to 0, or whatever element for which you wanted to check. This might have been the string you wanted to ask for. And you can even do this thing for arrays, or sorry, for vectors. Sometimes you have a vector of integers a, and you, after taking the inputs, you might like to write a condition like if a is equal to vector of integers having length n and having all the elements 0 or whatever. It just makes your code a bit uh, shorter to write. Okay, I hope that doubt is clear. Is this a combinatorics type question? Yeah, very basic combinatorics. What would be the equivalent rating of the question on CF? I think around 1400 maybe. I'm not sure. Okay, great. So let's continue. This is the problem which we have to deal with now. And many people might be like, hey, this problem is very easy. Even if you have solved something like Striveri to Z shape, which is very common. So you might feel that this problem is very standard. The idea behind this kind of problems, like you might find out this as a sub problem in a lot of problems on code forces and uh, Codechef on the easier side problems, basically for Dev 3, Dev 4 on code forces or even Dev 2 in Codechef. The way of solving this kind of a problem is, let's say the given string is 22112. You know that any substring which is starting from here or here must end like before this point. If there is a substring which is starting from here, let's say this is the start, then its end should either be this or this. No, it should never be on the right hand side of this line. Similarly, if a string was starting from this place, you know that the string must end before this point. No. Similarly, for this as the starting point, you know that it must end here before here. For this as the starting point, again, you know that it must end before this point. So basically, you know that all the substrings which can be created from this string are good. These are normal. All the substrings which are created from this string are also normal. Actually, these are not strings, these are arrays, my bad. So all these subarrays created from this array would be good. All the subarrays created from this would be normal, and so on. So you can just consider this as a separate array, then this as a separate array, and this as a separate array, then find out the number of subarrays, the good subarrays, which are basically subarrays of this subarray as well. So if the length of the subarray is n, or maybe let's denote it as m for now, then there will be m into m plus 1 subarrays which are normal. Now, depending upon what you people say, I can actually show you a derivation for why uh, it would be like this, or if you people are already comfortable, then maybe we can skip it as well so that the PCD would be a bit shorter. Okay, so I'm just asking a quick question. Do you people know that if you have an array of length n, then there will be n plus 1, sorry, n into n plus 1 by 2 subarrays in that array? Do you know about this? I hope this is common. Um, a quick explanation is, if you are considering the start point to be 1, the index 1, then there are n possible ending points. Basically, there are n subarrays starting from here. Then there are n minus 1 subarrays starting from here. Then n minus 2 subarrays from here, n minus 3 from here, and so on till 1 subarray from here. So there are this many total subarrays, which is equal to n into n plus 1 by 2. So for any subarray of length m, there are m into m plus 1 subarrays for that subarray, like subarrays of that subarray. There are this many. So what we can do is, whatever array we have, something like 1 1 1 2 2 1 1 1 2 2 2, we can just go from left to right. As soon as we find out this complete bunch of ones, we will just keep track of the number of ones we are getting. So we got 3 ones. We will have an answer variable with value 0 initially. We will just add 3 into 4 by 2 into answer, that is 6. There are 6 subarrays here. Then we got two twos together, a subarray of size 2. So we can add 3 to answer. Then we got another 3 ones. So again add 6. Then you got 3 twos. So again add 6. Basically this 3 came from 2 into 3 by 2. 2 into 2 plus 1, that is 3 by 2. And this 6 came from 3 into 3 plus 1 by 2. So you got 6. Somebody said two pointers approach. Yeah, if you want, you can use two pointers approach. If you want, you can just go from left to right and keep a counter for the number of same elements you have been getting so far and the element you have been getting so far. Both of them works. So guys, please say yes or no, whether you are with me right now or not. Do you have any doubts? And in case if I missed something, in case if I missed some proof for some place which you think I should have covered, then please mention it in chat. It would be good for the overall quality for PCD. Okay, if it is clear, let's move on to the code. In the code, what I did was, first of all, I took inputs. Then I went from left to right. I'm using a two-pointer approach for finding out the length of the block having all the same elements. Here, this is used for finding out the length. And then I just increased the answer by length into length plus 1 by 2. And then I did set I equal to j minus 1 because um, the code logic would have been going up like this. I have my I here. I would declare my j here. Then as long as ai and aj are same, I would increment j again and again. At some point of time, I would get my ai and aj to be unequal, like this case. So I know that the length would be equal to j minus I. And I would set my I equal to this value afterwards. And in my for loop, it would automatically get incremented as well. So this I, when I set it to this place, on the next iteration, it will start from here. And then again, the same process will happen. J will go from here, then here, then here, and then the same thing happens again and again. Somebody is saying in div 2 it has only 148 submissions. That is weird, but I don't know. I don't think the problem was difficult. I think that this was doable, and even the harder version is not much difficult than this. Okay, so I hope this code is also clear, and we can move on to the next problem. This is the last second problem which we will discuss today. The problem says that we have been given an array A of length n, and we can perform the following operation on it. Choose any contiguous subarray of length, subarray of A such that its length is greater than 1 and it is odd. Then delete the median of this subarray. If there are multiple occurrences of the median, then within the subarray, delete the leftmost occurrence. Note that the length of the subarray will decrease by 1 after the operation. Then they have given an example that if you have an array like 1 3 1 4 1 5 and you choose the subarray 141, then for the subarray 141 the median is 1, obviously. So the median is 1 and you will remove the leftmost occurrence, that is this one, from the array. So the new array will be 13415. 13415. And the problem is asking us, is it possible to perform the operation several times, possibly 0, on the array so that the final array A is non-decreasing? If it is possible, then find out a valid sequence of operations as well. And they have given a note that we don't need to minimize the number of operations. We only need to find any valid sequence. So even if it is possible to sort the array in only 2 operations, and we are using 8 operations, it is fine. So we have been given an array. Let's take an array here. 131145, 131415. I think, yep, this is the array. So what we can do is we can pick up any subarray having length greater than 1 and it should be got. Basically, we can choose any subarray of length 3 or length 5 or 7, 9, so on. So subarray size should either be 3, 5, 7, 9, 11, and so on. Generally, according to my experiences so far, this kind of problems are mostly solved by just using the subarray of length 3 in general. So the first thing which I did try on this problem was to see if for any array of length 5, uh, whatever I'm doing by applying, whatever I would be doing by applying operation by choosing a subarray of length 5, can I do the exact same thing by choosing subarrays of length 3? So this was the very first observation I did try and it didn't work out. So let's not discuss it. I just wanted to tell you about the intuition which I had on the very first go to see if uh, uh, whatever I can do with these subarrays, can I always do everything by choosing subarrays of length 3 as well? But it didn't work out. So maybe we can skip it. Okay. So the very next thing which I realized, okay, I think I would be directly telling you about the solution in this way, but um, to be honest, this was an easy problem in my opinion, or maybe we should call it as tricky problem. The problem is easy to solve. The only part for this problem is to observe that whatever array you have, let's say you have an array 1, 2, 3, or maybe let's say 2, 2, 3, 1, 5, 4, whatever array you have, um, maybe let's consider an array where all the elements are unique for now. uh, Whatever subarray you choose, you will remove the median element, है ना? And you have to choose a subarray of a length at least 3. So the smallest and the largest element of the array will never be a median of any subarray of length 3 or greater. This was the observation I made. Now, how will you make such observation? By just trying to look at the problem and think about maybe the sample test cases and get some general ideas. So in my case, what I did was I looked at this test case 3, 4, 1, 4, 5, 3, 4, 1, 4, 5. Let's say this is the given array and you want to make it sorted. You know, so what are the problems in this array? What is the thing which is not making the array sorted? This one in between, right? If you didn't have this one, the array would have been sorted. So naturally, I just got this aim in my mind that let's try to remove this one. And then I realized that, hey, whatever subarray I choose, if I choose a subarray of length 3, then sorting that subarray will, like if I sort that subarray, that one which I have would always be at the first position. Basically, the smallest element of the array would always be the smallest element of the subarrays. So it can never be the median. Hana? Even if I choose a subarray of length 3, the second smallest element would be removed. If I choose a if I choose a subarray of length 5, then the third smallest element would be removed. So the smallest element of the subarray can never be removed. And as soon as I got this idea, I just got the idea for the largest element as well. That hey, if I can't remove the smallest element, in the similar way, I can't remove the largest element either, because whatever subarray I choose, the largest element would always be at the end, and it would never be the median. So I can't remove the largest element either. So guys, are you with me right now? Or do you think that the observation which I told was not obvious? Like, do you feel that if somebody is actually just doing even hit and trial, even if you could not figure out the logic by just looking at the problem, even doing hit and trial can make you come across this tricky part, this observation, that you're never able to remove the smallest element or the largest element. So one obvious part is, if the smallest element is coming up, like whatever array you have, if the smallest element comes first and the largest guy comes later on, then one way for sorting the array can be just keep choosing subarrays of size 3. Eventually, like after every operation, the length of the array is reducing by 1 again and again. So eventually all the elements would be removed. Like you choose this subarray, so 3 would be removed. Then you will choose this subarray, 4 will be removed. Then you will choose this subarray, this 4 will be removed. Eventually you would be left up with the smallest and the largest elements only, है ना? So if the first smallest is coming first, uh, the smallest guy is coming first and the largest is coming later on, one way for sorting the array can be just remove all the other elements. And the way for removing all the other elements is simple. Just choose any subarray of any length. You would remove an element. You know that the smallest and largest can never be removed. Eventually, you would be left up with a subarray of length 3. And after applying an operation on that subarray as well, you would be left up with a subarray of size 2, where the minimum will come first and the maximum will come later on. So it is sorted. Does it make sense? Yes or no? I'm waiting for the responses. And in case if at any point you feel that uh, I'm not making obvious uh, things, then please mention. If you feel that something which I consider to be obvious here, if it does not look obvious to you, in that way, in that case, I would try to think of some even easier way for explaining the same idea. So, do you feel that this is going good right now, or you want to make some suggestion? Okay, if it is looking fine, then let's move on. Similar to this, you might get some idea that hey, it is also possible that the smallest guy, let's call this as mn for now, the minimum element, is coming up on the right hand side and the maximum element is coming up on the left hand side. Then in that case, whatever operations you apply, at the end of the day, the maximum guy is coming up before the minimum guy and you can't remove either of them. So your answer would definitely be -1 in this case, since you can't make it sorted in any way. है ना? So currently we have just considered the case if all the elements were unique. If the elements are not unique, in that case, you might have some confusion that, hey, I'm having mn coming up here as well and coming up here as well, and mx is coming up in the between. So should I consider that mn is coming up before mx or late after mx? You might have some confusions here, but at least for the case where mn and mx are coming up only once, it should be pretty clear that There can be two cases. Mn might come before mx. Here the answer is simple. Just choose the subarray 1 from 1 to 3. Basically, just choose the subarray, the first three elements a1, a2, a3, n minus 2 times. है ना? If you choose this n minus 2 times, your subarray, like your array size, will be reduced by n minus 2, and eventually you would be left up with only two elements, the minimum and the maximum guy. So this is a good way. You can get your answer in this way. So I hope this is clear. It's not difficult. And the other case, if mn is coming on the right hand side and mx is coming on the left hand side, then the answer is straightforward, -1. You can't really do anything here. But now the problem is, what if you are having multiple occurrences of, you have multiple occurrences of mn and multiple occurrences of mx? Then in that case, what can you do? So here as well, it's not difficult. You can just do some hit and trial. You can maybe just consider the case 114, or maybe 141 actually, something like 141. So if you have an array like 141 and you choose this subarray, then um, the median would be ones, है ना? The median value for this subarray would be the middle guy for this, that is 1, and we will remove the leftmost occurrence. The problem mentioned it here, the leftmost one, है ना? So this guy would be removed. If you had multiple occurrences of 1, the leftmost occurrence of 1 would be removed, है ना? So at the end of the day, the rightmost occurrence can never be removed, because um, if there is any occurrence of 1 present on the left hand side for this one, then obviously that occurrence would be removed if 1 is chosen as the median. And if you consider the case where all the ones on the left hand side have already been removed and this is the only one left, then you have got to the you have got it you have got this case where there is only one occurrence of 1 now, है ना? If all the other ones are deleted, then you have only one occurrence of 1, so it cannot be removed. So similarly, you can just find out for the largest guy as well that only the leftmost occurrences would be removed one by one. So eventually, we can actually say that the rightmost occurrences of mn and mx can never be removed, and the other people can always be removed if you just remove all the elements of the array. So whatever logic we had earlier, the only difference now is we will consider only the rightmost occurrences of minimum and the maximum guy, as we can remove all the other occurrences. And we can never remove the rightmost occurrence even if we want. Even if you want, you can still never remove the rightmost occurrence, because even if you get mn as the median, the leftmost occurrence would be removed before it. And eventually it will be the only occurrence left, so it can never be removed in future anyways. So yeah guys, is the problem clear? That is the whole logic behind the problem. The only tricky part was to observe this, that you can never remove the smallest or the largest guy in the array by applying the operation. So uh, yeah, this was the only tricky part, and the way I realized it was just by doing some hit and trial. That is what uh, I believe everyone would have done for observing this, unless someone who is super experienced with solving problems. Okay, so the main idea now is just iterate from left to right, keep track of two things, min index and max index. let's say these are the two variables which will keep track of the rightmost occurrence of the minimum element and the rightmost occurrence of the maximum element. So you can easily do it, है ना? Whenever you find out any element which is equal to the element or smaller than the element which is present at the min index, then just set the value of min index equal to I. And similarly for max index. And eventually, like at the end, you will just compare these two values, that if min index, okay, now there can be three things. Min index might be less than max index. Min index might be greater than max index, or min index might be equal to max index. Because if all the elements of the array are equal, in that case, min index and max index would both be equal to n. And in these cases, the answer is pretty straightforward. Just, okay, if the min index is greater than max index, then the answer is very straightforward, -1. For the case if min index is less than max index, then we will apply n-2 operations. Every operation would be 1 space 3, basically choosing a subarray from 1 to 3, then 1 to 3, and so on. If you want, you can use different operations. The main idea is just delete all the n-2 elements other than the min and max elements. And in the case where both of them are equal, either you can just say 0 and move on, or you can just say that, hey, I will still remove all the elements. I will just say here, if min index is less than or equal to max index, then in that case I would do this. I won't do anything special if min and max index are same. Because even when all the elements are equal to each other, this logic will still work, removing n-2 elements from the array. So I'm not sure which whether I did apply this operation or did I consider it, like, did I take care of the case where both of them are equal differently? And we can see it. So let me show you my code. I took the inputs, then calculated min index and max index. Then in case if min index is greater than max index, the answer is -1. Otherwise, I am applying n-2 operations. Every operation is on the subarray from 1 to 3. I hope this is also clear. So please tell me in chat, should we move on to the last problem? Yes or no? And does anybody have any doubt? Okay, great. So let's move on to the last problem. The problem is normal is good. We have already discussed the easier version of the problem. Now in the harder version, the only difference is here a of I can be as large as 1e3. Maybe, yeah, I think everything else is exactly the same this time. Like in the easier version, we were being given an array a, which in which ai would either be equal to 1 or 2, and we wanted to find out the number of subarrays. We wanted to find out the number of normal subarrays, basically the subarrays where mean was equal to median. And we had observed that if there is any subarray which has 1 and 2, and anything like which is having both 1 and 2 present, it can never be normal. Obviously, in this problem where ai belongs to 1, 2, and 3, this kind of subarray would still be bad, where you have only 1 and 2. You are having both 1 and 2, but you are not having any 3. Similarly, any subarray which is having 2 and 3 and more occurrences of 2 and 3, but no occurrence of 1, would also be definitely bad. है ना? Uh, but there can be some new good subarrays. Okay, let me just check if everything else is same. Yeah, everything else is the same in the problem. We have to find out the number of normal subarrays, basically the number of subarrays which are having mean equal to median. This median thing would always be an integer. We know about it. This mean thing can either be decimal or it can be an integer, right? So in the previous problem, this mean was the problem for us, or actually the good part for us, which made the problem simpler. Mean was decimal if you had both occurrences of, if you had occurrences of both zeros and ones, sorry, 1 and 2, and it was integer only in the case where you had ones and twos. You are having only one coming up again and again, or if you are having only twos in the subarray. If you have only threes, that is also fine. I know. The only better part is, even for a subarray like 1 comma 3, you can have an integer. Basically, if you are having any subarray which contains 1, 2, and 3, any number of occurrences of 1, 2, and 3, the mean would definitely be greater than 1. It would definitely be less than 3. Actually, greater than equal to 1, less than equal to 3. And it would be greater, it would be equal to 1 here, it would be equal to 3 here. And in all the other cases where you are having at least two distinct elements in the array, the mean would be at least 1 and less than equal to 3. Basically, sorry, greater than 1 and less than 3. है ना? So the only integer in this range is equal to 2. So the only extra task for now for us is find out the number of subarrays such that mean is 2 and median is also 2. ठीक है? We want to find out the number of subarrays whose mean is 2 and the median is also 2. Like in this case, the mean would be 2, but the median would be 1. And I think it is pretty obvious that any subarray where the number of 1 is equal to the number of twos, sorry, the number of threes, any such subarray will have the mean equal to 2 here, right? If you have, like, it does not depend upon the number of twos you have. The number of twos can be anything. It won't change the mean. Similarly, the number of ones and the number of threes can be anything. It's just that they should be equal. A subarray like 2 comma 2 can also have the mean equal to 2. A subarray like 132 would also have the mean equal to 2. A subarray like 1313 would also have a mean equal to 2. So we have like seen all three cases where 1 and 3 are not present, only 1 and 3 are present, or 1, 3 and 2 are all present. है ना? We want to count this kind of arrays where 1 and 3 should have equal count, even this kind of subarrays where 1 and 3 should have equal count, and 2 should be present. Otherwise, 2 can never be the median if 2 is not present in the array. And we don't want to count these cases because they have 1 and 3. So they have the mean equal to 2, but they don't have the median equal to 2 here. So in a nutshell, we want oh yeah, one more thing. Any subarray which contains equal number of ones and equal number of threes, after sorting it, it would look like this. Let's say we have 3 ones, then 1, 2, or maybe 3 occurrences of 2, and then 3 occurrences of 3. So the median is always the middle guy in the sorted array. है ना? It would be this guy. Even if there was only one occurrence of 2, it would still be this guy. Even if there were only 2 occurrences of 2, there will be this guy. Basically, if you have even a single occurrence of 2 in an array which is having equal occurrences of 1 and 3, this array will always have the median equal to 2, because 2 will always come up in the middle. Now it doesn't matter how many times 2 is coming, it would definitely be the median. I hope this also makes sense. It is also just an observation which you should have ideally made. Ideally, you should have made the observation when you would have been trying to think more and more on solving the problem. Now, uh, yeah, so now the task is we want to find out uh, the number of subarrays which contains only one, which contains only three, and the number of subarrays which contain count of 1 equal to count of 3. है ना? So even all the subarrays which contain only 2 would contain the count of 1 and 3 to be 0. They would be equal. So in this kind of subarrays, these cases are also covered, where you have only 2 in the subarray. That is why I have not explicitly mentioned it as this case, because we would already count it in this case. Um, so we want the count of 1 and 3 to be equal, and the count of 2 to be at least 1. So how many of you are with me right now? Just say yes. And if you are lost already, if you miss something, if you have any doubt, then please mention it, chat. Uh, what would be the equivalent rating of unmedian question on code forces? I think it should be around 1400, but I'm not sure about it. Like in my case, it didn't uh, take me long to solve the problem, so it might actually be having a lower rating. Okay, so I see nobody asking any doubt, and you are with me right now, so great. Doing this task is easy. We have already done this in easy version as well. This is also an easy task. You know, how will you make sure that you are finding out the number of subarrays where the count of 1 and 3 are equal? Let's just forget about this condition. Let's say that if you just had this condition that count of 1 and 3 should be equal, how will you do it? And then we can think about adding this condition as well. So it is like you have been, yeah, just to mention, I think it is pretty obvious that we have broken down that difficult problem into these three sub problems, and all of these are independent of each other. Its answer does not depend upon other, its answer does not depend upon others, and its answer also does not depend upon others. So 1 and 2 are easy. Let's think about the third one. If you have an array like 1 3 1 2 3 1, you want to count all the subarrays like this 1 comma 3, this 3 comma 1, this 3 1 2, this 1 2 3, this 2 3 1, this 3 1. I think there are too many. I hope I didn't miss. I hope I didn't miss. Yeah, I have already missed it. And this subarray also is also there. 1 3 1 2 3, and similarly this subarray 3 1 2 3 1. These are all the subarrays which have equal occurrences of 1 and 3. And now we want to just find out the count of all the subarrays where 1 and 3 are coming up equal number of times. Now let me tell you about a pattern. This is a subproblem. You might come across some problems which, after breaking down the problem into subproblems, one of the subproblems is that in a string you have some A's and B's and maybe some C's as well. And just 1 second. Yeah, sorry for the inconvenience. Okay, so if you have a string like AB, AAB, CB, CCB, and you have to find out the number of substrings where count of A equal to B, count of A is equal to count of B, and there can be some similar subproblems in some different problems. There is a very common way of solving it. It is like, consider the A's as 1 and the B as -1, and whatever string you had like A, B, B, C, A, B, just consider this as now an array having 1 1 -1 -1 0 1 -1. We have considered these A's as 1, B's as -1s, and C as 0. And now all we have to do is find the number of subarrays with sum 0. And this is a very standard problem. You can find it in Striver's A to Z sheet as well. The number of subarrays with sum equal to 0. This is a common problem in which we use a map, or you can use a vector in this case as well. Like in this problem, you can even use a vector, but in general, you can use a map of integers count for keeping track of. Uh, it is like, let me show you a diagram. If you had 1 3 1 2 3 1 1 3 1 2 3 1, this array, we go from left to right. We keep track of this count array. Initially there is zero prefix, there are zero prefixes, sorry, there is one prefix having the sum equal to 0. So here we are having the sum, and here we are having the count. We have one prefix having the sum 0, basically the empty prefix which does not have any element. Then our I will come to this point. We will see that the sum till this point from the beginning is 1. So we have found one prefix having the sum equal to 1. Then we move on till this point. We will see. Okay, sorry, my bad. We had to convert the uh, ones and threes into, like, let's say 1 will become -1, 2 will become equal to 0, and 3 will become equal to 1. And we will have to find out the number of subarrays having 0 sum. So the array will become 1 -1 1 -1 0 1 -1. So we have one prefix with -1 sum, one prefix with 0 sum, and our I has reached to this point. So now we have one prefix having the sum 0, another prefix having the sum 0. So now we have two prefixes of sum 0. And now we can maintain an answer variable 0 initially. At every I, as you saw that this is the prefix having the sum equal to 0. है ना? And you knew that there was already one prefix having a sum 0. So if you have a prefix till this point having the sum 0 and you have a prefix till this point having the sum 0, doesn't it mean that there is a prefix, sorry, there is a subarray having the sum 0? है ना? If you have a prefix with, let's say, some x and another prefix having some x, then the subarray starting from the next point of this, basically, if this prefix was till this point, then the subarray starting from the next element till this current element will have the sum equal to 0. है ना? Right? In this case, the sum is -1 here. The sum till this point is also -1. So this subarray must have the sum equal to 0. We are using this idea for counting the number of subarrays with some 0. Anytime whenever we find out a prefix with some x, we just go to the map and say that, hey, tell me the number of subarrays having the sum equal to x. Sorry, the number of prefixes having the sum equal to x. Let's say map returned this value count x to be equal to 4. Then you say that, hey, there are 4 prefixes which I can remove from the current prefix to get 4 different subarrays for which the sum would be equal to 0. The subarrays will have the sum equal to 0. So I will just increment answer by 4. Now I was just willing to give you some idea of the way in which we calculate the number of subarrays with some 0. I would highly recommend you to just go to Striver's A to Z sheet, or maybe just search about this problem on Chrome. You will find out lead code or GFG link and try out the problem there. You will definitely find out a lot of resources online as well. So solve the problem, that one first, and then come back to the problem. Try to solve it on your own. If you still can't solve it, then watch the rest of the explanation. So, and now I'm assuming that this is actually considered to be doable, that you can find out the count of 1, the number of subarrays having count of 1 equal to count of 3. Then this is now the hardest bit of this problem, that you have to find out the number of subarrays having the um count of 1 and 3 to be equal, but the count of 2 should be at least 1. So if you're someone who has done practice of DSA but is new to competitive programming and is not very creative with the way of writing, basically thinking about the logic, then this might be difficult. But we can use a creative way here. The way in which I solved it here is, I said that I will first of all figure out the number of subarrays having count of 1 equal to the count of 3. And then from there, I will subtract the number of subarrays where the count of 1 is equal to count of 3 and the count of 2 is 0. Now, this thing is something I already know how to do. Again, and for doing this part, let's say you had a subarray like, let's say you had an array like 1 1 -1 0 -1 1 -1, something like this. You know that you don't want to consider the subarrays where you have a 0. So you can just say that, hey, I will consider this as one array, whatever way I knew for finding out the number of subarrays with some 0. I will just use it here, and I will use the exact same way here, and I will just consider like this is different array, this is different array. We'll do everything on them independently. They will have no relation with each other. So in that way, I can just make sure that, hey, I will consider all these subarrays, and then none of those subarrays you will have any zeros. So this is also an easy thing. This is also an easy thing. Although you could actually do this using two pointers. This is not a difficult thing. Earlier I had written this code, but I thought that for PCD, this would be easier to discuss. This would be easier to understand. So yeah, the logic is simple. You would have created a sum variable, maybe initialized with 0, and you would have a count variable, this count map. है ना? So every time you find out a 0, just clear this count map in the same way as you had initialized it, and set the value of sum equal to 0 in the same way as we had initialized it. And in the initial stage, before iterating over the map, before iterating over the array, we had set count of 0 equal to 1 because we have an empty prefix which is having sum equal to 0. So in the same way, just set count of 0 equal to 1. This is a creative way of using our knowledge, not really having a complicated code, and you are able to use it in more ways than one. Okay, so somebody is asking, what if all the elements are 2? Okay, so in case if all the elements are equal to 2, your array would look like 0 0 0 0 and so on till basically all zeros. Okay. And for the part of the number of subarrays where the uh, sum is 0, eventually you would actually count all of them one by one. Initially count of 0 would be equal to 1. Then when you will reach at this place, you would add 1 to the answer and this will become equal to 2. Then when you will reach I equal to this place, then you would add 2 and you will make it 3. Then you will have I at this place, you will add 3 to the answer and make it 4 and so on. So eventually n into n plus 1 would be added. And for the part of this subtraction thing, this part, you will see there will be no points where you would apply this logic, because every time you will just find out a 0 and you would uh, do this part of clearing the map and setting the sum equal to 0, and basically everything will be reset. So does this answer your doubt, or was it out something else, basically at some other place? And uh, is this problem clear? How many of you are with me right now, and how many of you are lost somewhere? Maybe my explanation was not up to the point and you have some doubts, so you can ask them in chat. And somebody is asking, Raghav, share your Google experience, what they asked you in interview and last moment tips. I will share this after the end of the stream, after the end of the session. Okay, so for now, should we move on to the code part, or does anybody have any doubt? Code, okay. First of all, I took all the inputs. Then I created this map and initialize the sum by 0 and initialize the count of 0 with 1. Then I counted all the subarrays with equal number of ones and equal number of threes. So I did it in this way. Yeah, by the way, while taking the inputs, I had already reduced the value of all the elements by 2. So my array of 1 to 3 became an array of -1 0 and 1. And this part of code will actually find out all the subarrays with sum equal to 0. Then I have been finding out all the subarrays where the sum is 0 and there is no 0 coming up in the array. Basically, there are no 2's coming up in between. So whenever I find out any, whatever count I find out, I'm just subtracting it from answer, and whenever I find out a zero in the array, I reset everything. I reset the sum variable, I reset the count map and the value of zero. So this is also pretty straightforward. And at the end, I'm just adding the number of subarrays, which is having the nu- uh, which is having only ones or zero or threes. So in case if AI is equal to zero, I would have already considered, I would have already counted all the subarrays containing only zeros. So I'm adding a continuous statement here. Otherwise, I will just do it in the exact same way as we did in the easier version, and then I'm printing the answer. So I don't think it was difficult in terms of code part. The only difficult bit of this problem would have been this part on thinking about this. Um, and I think for the Dev 1 people, this was also not difficult. For the Dev 1 people, the problem was actually easy. But for Dev 2 and below, this could have been a good problem. So if anybody has any doubt, then please ask. Otherwise, we can end the stream. Okay, great. So thank you for watching the video and bye bye.